Okay, so example 4 is just practicing what we just did. So we're going to take these two functions, we're going to compose them, but we're also going to evaluate the compositions at certain numbers and finding their domains. So I would say first pause the video and work on these first 4 problems. Okay, I just finished. Hopefully your answers and my answers line up. It's really just about getting the compositions of the order right. G of -1, that is -2. Plug -2 into F, and you get -1. F of 0 is -3, right? And then plug -3 into G, and we get -2/3. F of 2 is 3, and F of 3 is 3/2, and then G of 3 is 2/3, and G of 2/3. This is the only kind of tricky part. 2 divided by 2/3. Divide by 2/3, it's the same thing as multiplying by 3/2. The 2's cancel and we get 3. Next, I'd like you to work out the formulas for these compositions and simplify them if you can. Okay, I purposely did not simplify this too much, just to make sure that we're all on the same page. We're plugging 2 over x into f. Okay, so that's this. So we get 2 over x minus 1. This is 2. The next one is g of 3 over x. We're plugging 3 over x minus 1 into g, so we have 2 over that. Here we're plugging f into itself, and here we're plugging g into itself, so that's how we get these last two. Okay. Now we could simplify these if we wanted to. In particular, we can see that this will be the same thing as 2/3 times x minus 1 when things are defined. And down here you might be tempted to say that this is 2 divided by 2 over x, which is x, and that's true when things are defined. Over here, if we wanted to, we could multiply and divide by x minus 1, and we would get 3 times x minus 1 over 3 minus x minus 1. Okay. Now the caveat here is when you're trying to find the domains, you really want to look at these expressions before you go to anything else. So we can see, like, if we wanted to find the domain of this, x can't be 0. X can't be 0, and we can see that x cannot be 2, because if 2 over 2 is 1, 1 minus 1 is 0. There are two denominators here, right? So the domain of f composed with g would be all x not equal to 0 or 2. All right, because we're getting that last 2 from 2 over, solving this equation, 2x minus 1 equals 0. Okay. The domain of g composed with f, I think you can see from here, x cannot be equal to 1. Okay, as long as x is not equal to 1, then this is equal to 2/3 times x minus 1. So x can't be 1, so it would be all x. X not equal to 1 would work. Now, once again, we can see that x can't be 1, but we also see that 3 over x minus 1 cannot be 0. Okay, if we try to solve this to be 0, that means 3 over x minus 1 equals 1, and that means 3 equals x minus 1, and so x would be 4, right? And we can see that, and sure enough, if we plug in 4 here, or actually if we plug in 4 here, we get something that this expression will be undefined. So for f composed with f, this would be all x not equal to 1 or 4. And then finally, for g composed with g, we're taking 2 divided by 2 over x. Well, we can't divide by 2 over x if 2 over x is undefined. So once again, we need this to be all x not equal to 0. Okay. Even if x is not 0, then of course everything simplifies and we get x. Okay. So these would be the domains. And that's hopefully your answers lined up with my answers, and we'll be using this to talk about inverse functions in our next video.